Now we will move forward for LangChain framework. So LangChain framework allows us to build LLM based application. This framework consists of several open source library. First one is the LangChain core. Next we are having a LangChain community. After that we are having a LangChain. From there we can import the chain, agent or retrieval strategies. LangGraph we are also having LangServe. Then last one is a LangSmith. So main three things we need is LangChain core, LangChain community and LangChain. So these open source library we will use and we will going to build the application on that. Sure, let's see how to build a project with the help of LangChain. So this is my GitHub repository, NextGen AI guy. If you want to have this code, that GitHub repository link I will give into the description. So first what we have to do, first we have to install these packages into the terminal, or you can write this LangChain community or sentence transformer into the requirement.txt file. Like here it is, in that requirement.txt file you can write all this packages name. In your terminal you can directly run pip install -r requirement.txt file, which will going to install the all packages which is mentioned in the requirement.txt file. After that we are importing the libraries over here. First we are importing the directory loader, which allows us to load the documents from the given directory. Next we are importing the Chroma, which is the vector database where we are storing the text data after converting into a vectors, which is numerical representation of text. That one we are storing into the Chroma database, which is open source and you can store into locally as well. So after doing that we are importing recursive character text splitter. This is the splitters we used it to split the whole document into a manageable chunks. This recursive character text splitters split that whole document recursively till the end. After that we are importing retrieval QA from LangChain.chain. So this is the retrieval QA chain which allows us to combine all the components in a one chain. So after doing that we are importing sentence transformer embedding from the LangChain_community.embeddings.sentence transformer. I have already shown you that sentence transformer we can use it to import embedding models. So that sentence transformer we are importing from the LangChain community. After that we are importing the sentence transformer embedding. Next we are importing the Hugging Face hub from LangChain community.llms. After that we are using the JetGrok, which I have told you that we will see that how to implement LLM model from the JetGrok. So after doing it, here we have passed our directory path. Here you need to define your directory path from where you wanted to load the documents. After doing that, initiated our directory loader, which we have imported over here. So in that directory loader we will going to pass our directory path, and this show progress will going to show you that in the terminal that how much it has loaded and how much it has left. So here we have initiated our loader.load. It will going to load the all documents from the given directory. Next we are splitting our documents with the help of recursive character text splitter. Here we have provided the chunk size is equal to 200 and chunk overlap is equal to 20. Means the whole documents will be split into a 200 chunk size, or you can say a 200 words, and chunk overlap is a 20. Means for example purpose, if the whole document is split into a 2 chunks, so first chunk's last 20 words will be present into the next chunk first 20 words. So both first chunk last 20 words and the last chunk first 20 words will be same. Here we have initiated our splitting documents, which will going to split the document recursively. After doing that we are just loading the embedding model from the help of sentence transformer embedding model. Here we have passed the name of the embedding model. We are using all mini LM6 v2. If you are using for a production level project, please change this one by looking the leaderboard in the embedding model, which I have shown you in the Hugging Face. From that leaderboard you can find out the best model according to your need. Here we have passed the persist directory path where we wanted to store our database locally. So this Chroma vector database allows us to store that vector database locally or in your disk. Here we have initiated our writing from documents. and this one we will going to pass the document which is splitted by the recursive character splitter, and then we are passing the embedding model which we loaded over here. After doing that, we are passing the persist directory, is where we wanted to store our database. If in case if you wanted to use other database like a Face CPU, it is developed by the Facebook. It is also open source. It supports the persist directory function also. If you wanted to use a face vector database, then you can uncomment this one or comment this chroma database, and you will be able to save the data into this face database. Next we have a retriever function. This is the vector database which we have over here. We are using as retriever function which allows us to retrieve the document based on the query. So we have three kind of retriever. The first one is just a simple as retriever. By default it will going to use the MMR, means maximum marginal retriever. The next one is a similarity score threshold, means if you are writing a query, then it will going to do the similarity search from that document. So that similarity score threshold we can provide over here. We are giving the similarity score threshold is equal to 0.5, means if the similarity score is above the 50% between the query and the document, only those retrieved documents we need, not below the 0.5. So that also we can define over here. Here we pass the search keyword arguments. K equal to 1 means how many documents you wanted to retrieve. If you wanted to retrieve more than one document, then you can change these key values from 1 to as number of documents you want to retrieve. Here we have used the large language model from the Hugging Face. Here we have passed the repo ID which is Google/flan t5. In the Hugging Face we have seen that in the model section we just need to choose the whatever large language model we want, and that repo ID we can write over here, and the model keyword temperature we are providing 0.5, which range between 0 to 1, means 0 is quite less creative and 1 is more creative. And the max length of 512 means whatever the text it will going to generate, that maximum length is going to be 512. I told you that I will show you how to use the chat grok, means grok LLM model also. So we have imported this chat grok from the LangChain underscore grok. We can define the any model which is available on the grok platform. So in this case we have provided the temperature is equal to 0, model is equal to llama 3. So any models if you want, that model like Mistral or llama 3.1, that model's ID you can pass over here, and here you need to pass the API key. After doing that, we are creating a chain. So chain is allows us to combine the all components in a one single chain. So here we have used a retrievable QA chain. From that one we are passing the turbo LLM, means large language model, the vector store retriever function, and the return source document is equal to true. That source documents also it will going to retrieve. And here we just have to pass the instruction to the LLM model like warning, whatever you want instruction you want, you can give it over here. Here we are passing the question with respect to warning plus you are a helpful AI assistant. Your job is to generate output based on the query. Here we are taking the query. When you will run this code, so this will going to ask you to write the query. So that query we will going to pass, and we will pass that query into the QA chain. So that QA chain which is over here will going to first retrieve the data from the vector store retriever, then it will going to pass to the large language model, and then large language model based on the query and the retrieved data, it will going to generate the final output which will be printed over here. So that's how we build a project with the help of LangChain. So I have shown you how to build the project with the help of LangChain.